Introduce myself. I'm Vishnu. I take care of cloud and agentic training. I'm sharing my screen.
Okay.
Hope you are able to see.
Yeah, now I can see. Yeah.
Okay. So the course, what we are going to deal is with multiple agentic AI solutions. As you are well aware, right? There are different models available in the market. So we need to look at from an angle of, see, intermediate would be basic to intermediate would be understanding what is an AI, what is the difference between an AI agent and an agentic AI workflow, how you can actually look into MCPs,
Mhm.
model context protocols, how you're going to use ops for telemetry. Okay, so
Yeah.
classification would be from the orchestration part, as you
Mhm.
were rightly mentioning, and then we have observability. Okay,
Mhm.
then we have RAGs. So RAGs come with deep evaluation or retrieval augmented generation using grounding. So there's an advanced RAG which we have implemented. So we'll touch upon use case on the same. Then
Mhm.
basically deployment on a cloud infra. So we choose GCP because a lot of Gemini workload our client is also actually using.
Okay. Okay.
So let me just jump on to each of them.
Mhm.
So beyond your regular way in which ADK or an agent development kit is being used, we will transition to DAGs. So DAGs are directed acyclic graphs. Okay, Apache Airflow Composer service is available in Google, and it
Mhm.
has been implemented across different models. LangGraph also uses the same for complex branch decisioning making. Similarly, we have React loops, okay, reasoning and acting, that is React. So here we are going to have agents take up the query, select a particular tool based on the domain. It is context aware and it reflects on certain sequential actions to generate output without any generation of even a query. If you want to generate a report and then analyze it and send it at a particular time over email, it is multi-agent. So one agent may prepare the query. Another agent may generate the report. Another agent may convert it into a PDF and attach over a scheduler to an email system. Okay. So
Mhm.
those would be the reasoning and act cycle which we can design. Then we will have concurrent parallelism. So this is where the APIs are generated for large data processing and enterprise workload, where a lot of request response time becomes a challenge because I don't want 5 minutes for my job to run. I want it to be run within say 30 seconds, 45 seconds. So and that too, it is not a single workflow I want to run. I may need to run 10 of them parallelly. So concurrent parallelism is also achieved using multi-agent system. Then human in the loop. So here again, since it is artificial intelligence and we need to validate and confirm and also revalidate for certain approvals. So we will build deterministic gates for critical approvals. This is going to help you in risk management for maybe sharing a financial information or even provisioning a cloud resource as an uh, not to scale up too many resources or build an AI which may consume most of your cost because most of these large language models run with a high price. So we need some guardrail to prevent it as well. Okay.
Okay. Okay.
Then moving ahead, we have MCPs. So MCP Model Context Protocol. This has been the cognitive layer for identifying the data sources, building the MCP host, integrating with either OpenAI, Gemini, or building a client which can understand your uh, components. So you know, right? The every laptop or a computer has an USB. So somebody would not have designed the USB with a specification of size. We may not be able to plug in any external devices, correct? So here, from that concept of universal serial bus, we have evolved to USB for charging. So we had the A type, B type, and C type, right? So we are going to use USB-C for AI. This is going to prevent any vendor lock-in. So you can have N type of vectors with M cross complexity. Okay, so we're going to come up with many to many kind of relationship establishment or rule one to rule n summation as per your complexity of your agents which can outline can also be there. So MCP servers will have all the resource tools and prompt which you define, and all are backend handled by databases or services or even files, which can be your grounded documents, PDF, Excel, CSVs, etc. Now, we will use Python to build an MCP server and run the components. So we will be using extensively uh, the Google product suite because a lot of services are free for us to use. Certain things are chargeable, but we will try to use Google credits for setting it up. Then we will have a maker checker function. Okay, there's a helper function which we'll develop, and we'll implement the MCP tool. Once we configure it, then we will have it invoked from client. So basically, we'll build an agent and then deploy it. Then the deployed solution only we are going to consume, okay, as an end user. So this also leads to an understanding of architecting plus dynamic evaluation based on the rules or the permissions what we specify. We will go and use the JSON formatted remote procedural calls for managing the MCPs as well. Okay.
Okay.
Then we will move on to an area which is getting developed. Earlier it was agile first approach, then cloud first approach, AI first approach. So then came agile operations, cloud operations. Now it is agent operations. So we're going to build end-to-end traceability. So we'll use Landsmith or Agent Ops to have conversational trees built, and each LLM call will be associated for each of the keys which are being consumed. Because basically behind the scene, we consume API tokens, input tokens, output tokens. We will have this telemetry mapped so that we will not go and reach a saturation level or an inflation level, because optimizing cost is something which we need to identify whether our logic is going in a redundant reasoning loop or inefficient way in which components or parameters are defined. So we'll have to understand how many tokens are consumed either in my input phase or during the generation phase in output. Then we go ahead and put all the cases within a component, which we call as a sandbox, where we will not impact the existing DB servers and the workflow which you already built. So this will be something like a standalone, which you build and use. Then we will also look into observability for anomaly detection. So the system hallucinations, which may deviate from the defined guardrails, or you're not getting the expected output. Either there's a problem in the logic or the AI is not able to retrieve it. Then this comes with small models, but large language models normally will give you an output, but you need to validate it again. So you will have to look into from an angle of prompt engineering, prompt injections to avoid these hallucinations.
Okay, so you are also going to cover tokenization, you mean?
Tokenization, yes, because it's a costly service for consuming tokens. If you use non-GCP model like Claude, or see, we have Gemini Flash, which we can consume up to 150,000 tokens. Okay. Beyond that, there's a cost, and who needs to bear the cost? All the attendees of the session would be bearing it. Okay, or you can build it on your own with your account and then use it. Then we'll do a rigorous AI evaluation. This is where we look into the core metric of faithfulness, relevance.
And just in the respect of previous slide, I am just asking one question.
Sure.
Are you also going to cover like casing?
Casing means?
Casing means like, let's say I write the prompt to get some details. Okay, let's say give me the details of 100 EC2 instance, which is having, highly utilized and all those things. Okay, for example.
So that is implementation on AWS, right? So what would happen is any of the what do you call costing factor, right? It is your agent solution. It is not part of the component, because see, eventually the large language models are always used for different use cases specific. So if you have a use case which you want,
I mean to say in perspective of token, let's say I use that prompt. Okay, at that time it consumes some tokens, right?
Yeah.
And next time if I'm using same kind of token, so it should not consume that token.
That is called as prompt caching.
Yeah.
So you said something else. I didn't actually.
So I said casing only. But I don't
okay. Sorry, I heard as casing. It's caching. Okay, understood. No problem. So we do that because see, any repetitive query, I don't have to rerun and consume my input tokens, right? I already have generated, and it is context aware. So we'll use prompt caching.
Okay.
Yeah, system prompts and few short examples with large reference models we are using.
Mhm.
I don't use it with AWS. We have a project which is consuming currently for Google. So we'll
Mhm.
use prompt caching with GCP. So
Yeah,
basically,
that's
some of the
really good.
implementation, yeah, some of the implementation demos would be done with Google Cloud Platform. Okay.
Mhm. Okay.
Yeah. Then coming to the core metric, as I said, the four parameters of AI evaluation, we'll use RAGs, okay, LLM as a judge, or programmatic check and GitHub actions if you are using any integrated deployment pipeline. Now, for example, a faithfulness score evaluation can be total claims in answer verified by the context divided by total claims in answer. It should be above 90%. I cannot assure 95% also. It should be above 90% for the system to be actually evaluated. Okay. Why I'm having a 10% variance here is that is based on your model. If you use a lower end model, obviously there will be a deviation in your output. So it is how you train your model or the model, how it has been trained. With large data sets, if you consume Gemini models or Gemma models or Lang or even Claude, I think those are always giving 0.9. I mean, out of 1, it is 0.9, which is 90% and above. Okay.
Okay.
Yeah. Any questions? So beyond that, this is the last part from intermediate to advanced. We will go for graph wrap fabrics. We have something called as HNSW, which is hybrid search vector, and graph with knowledge triples. So we will see any 3 points can be joined to form a triangle or a triage. So we will go and understand what is a triage, what is my semantic relationships. Then we'll also bring in something called as corrective RAG. So RAG would be for grounding purpose. So I don't want my model to look outside the environment where I'm working. So I'll ground it to a RAG. It can be a file, it can be a drive, it can be your SharePoint, your OneDrive, okay, with a lot of documents. You can supply 1,000 plus PDFs and ask to derive information only out of it. But again, corrective RAG after reasoning and memory, it can see the LLM model and the agent, right, as a close relationship, or it is context aware. Now, if another user asks, but it may have a tendency when we are using prompt caching, right, to fetch in the details which are already available. Now, what we do is we will autonomously grade the chunk. If it is irrelevant for the user and the user gives a second prompt or retypes a prompt thinking that I gave a wrong prompt, now it does a corrective RAG. It will go and fetch the details again. It's like index the information will be uh, flushed out. Okay, basically I can say that it is not like a time to live, but the caching would be re-entered. So we will have a cache miss over there and it will work. Then we also have a hybrid search based on keywords. There is a self-RAG decider, dynamic decision node for retrieving information. This will reduce latency and token overhead. One advantage of this would be that the semantic search or complex queries which you are running, right, can actually be integrated with your agent much similar. Okay.
Okay.
Yeah. So this will be the last part. And finally, infra and security. This is where we go for cloud native deployment. Either you develop the agent and deploy it as a container within your Kubernetes running your pods, or you will go for additional layer of security by having some more guardrails. And there are DLP, which is available in Google for PII masking, because right, a lot of personal identifiable information comes in picture when you're fetching details, and then it's purely on your use case. It can be on banking, finance, security, insurance, etc. So we will cover identifying data encryption, how to protect sensitive data, how to limit the data which is getting shared, how to train the users to support your system because it's a shared model on cloud, right? Then we will prevent extending the services being stored into devices. Okay, put data protection policies in place. Do not allow anybody to take it outside your office network. Then routinely test your security system. So every 3 months, 6 months, plans would be derived for security. Then monitor any third-party integration. So if you're using the Claude model or the Gemini models, we'll have all this what do you call integrations part of the compliance and NDA which would be available. So we can think of either using AWS Bedrock and a private link, okay, or we will go for Gemini model, okay, with the dedicated cloud interconnect service. Okay. So why I said both, because implementation level, initially we had a scenario where we were using AWS with the Google environment, but there was a challenge of integration. I mean, I shouldn't say integration. It is a challenge of two hyperscalers. Okay. It was a polycloud solution, I should say. Now, what we went ahead and moved from Bedrock to, we have moved on to Vertex AI, which is nothing but the Gemini agent platform, and we are using it extensively nowadays. We have removed the dependency on having the model developed initially with Bedrock. Then these are the capstone projects which we will be covering: banking or insurance fabric. So we will look into the transitions of claims for processing integrated with core banking API, human in the loop approval for any payout for claim greater than whatever $10K you can specify. So here we will use LangChain, MCPs, and Vertex AI from Google. Then there is another capstone project which is on DevOps. This is for anyone who comes from a DevOps background to integrate SRE agent for monitoring EKS logs, generating remedials, and verifying the workflows in your CI/CD environment. So CI/CD at an UAT level or a dev level we'll look into, where we will use AgentOps, Kubernetes, and Cloud 3.5. Okay. Any questions?
No. So 2 projects you are going to cover, right?
2 projects are there. You have to complete any one of them.
Okay. So are you also going to cover like fraud analysis or something for finance domain?
So it depends on the use case which you want to look into. Are you looking at, see, normally for any of our regular training, it will stick to a curriculum. Okay. Anything of your nature, it's like on the job training, right? So those can be discussed, but I cannot assure that I will cover it. But based on your, because see, somebody has to develop the Python code for deployment within your agent. So the curriculum is designed in such a way that basic to intermediate, intermediate to advanced is covered. Some of them, normally when we have a batch, right, they might not know what is an AI agent. I cannot tell on day one what is a RAG. So initial few days would be some concept, some theory plus hands-on. Okay, currently I have a batch of 4 members who are working on Agentic AI on GCP, purely Oracle Salesforce guys. Their requirements are completely different. I mean, they have come for on-the-job training actually, because they have workloads running on Oracle and they want to automate with the help of an agent. They want to read and write from the database as well as have an agent develop the queries for them, generate the report. So we are building multi-agent system over there. So it's more like on-the-job requirement which is there. But for a course, it is having its own structure, its own labs, which will be covered. I think. Hi, Yogesh.
Okay. Fine.
Yeah, any questions you can ask.
And will you also going to cover like embedding and UI, all those things? Like let's say we build some agentic platform agent, right? Now we want to embed that, and we want to bring it to UI so that user can give the prompt from there, and
that is normal only. See, only thing is when you do it from your end in your account, it is your account, you do it. If you want to deploy it as a solution, there is a lot of cost involved. Because when you want, the moment you develop an agent, right, you can test it locally, you can have a UI prompt. Normally, I think last month we had a hackathon for Agentic AI, okay? So one of the requirement was to build a UI. I mean, UI building is fine, but where it runs from my system to the cloud, which I am choosing, which is my GCP. Now, if I have to deploy it and give it to end user for prompt testing, then there is something which is heavily cost, because model and token consumption will be n into x times, right? I mean, n would be my cost, x would be the number of user cost. So the number of user query, again, I have to bear the cost because it goes from my account, my credits, and your bill by the end of the month would be very huge.
No, just for testing, like we are not going to
testing certainly in your environment you can build and test, not a problem. The prompt you can generate. So we use Gemini for it. I mean, when I say Gemini, it's a Gemini agent platform which is there. So earlier it was called as the Vertex AI platform. Now it has been evolved to Gemini Agent platform.
Okay.
Yeah. Hi Yogesh. You can introduce yourself, Yogesh. You can unmute. So normally we design the curriculum in such a way that if there is a fresher, we'll cover and ensure that the basic to intermediate concepts are understood. It should be made, I mean, they should not feel like directly we are jumping onto a solutioning kind of thing, right? All right. Any other questions? Anyone?
No, I don't have any.
Okay. Yogesh, you want to ask something?
What is your name? Actually, I missed your.
Vishnu.
Sorry?
Vishnu.
Vishnu. Okay.
So I had done my MS in cloud, and I have been working since last 17 years. Last 15 years on cloud, I should say. Okay, from 2012.
Okay. Fine.
Anything else, Yogesh or Inder, anyone? I think we are good. Thanks for your time. Hope you had a good demo and discussion. Thank you.
Thank you.